And now Cesco Reale with the games in 4 dimensions.
Merci beaucoup, thank you very much. D'abord, une question linguistique. Qui ne comprend pas l'anglais ou comprend peu l'anglais? Ok, donc I'll do it in English without any problems. Okay, so first of all, I would like to thank the Swiss Museum of Games for organizing all that. I'm very glad to be here, and really, I think the most enjoyable thing is to have met you all here. It was a really great pleasure, and I think the start of some collaborations. Another small thing, please interrupt me. So as soon as you have questions, interrupt me. I don't care if we'll have time to finish the last things, it's not really important. More important that I'm clear, and so if you don't understand, it's my fault. So, okay. So first of all, one small question for you. In how many dimensions do we live? 3, 4, 4. Georges? 1.
Actually, 12 or more.
Yeah.
In the function space.
Yeah. Okay. Exactly. This is the closest answer. So, according to the string theory, one of the most recent physical theories, our universe is in 11 dimensions. And why do we perceive only 3? Well, the answer is that if you take, for example, a piece of paper, you clearly see 2 dimensions, but the third one is almost too thin, so you can almost not see it. And by analogy, the dimensions over the third, according to these physicians, are energetically too low to be perceived. But still, it doesn't mean that our world is in 3 dimensions. According to some theories, there are more dimensions. And so that's why the interest of studying dimensions over the thirds. Now today I will talk only about the 4th, maybe next year about the 5th, and so I have 7 more talks for the 7 next years. We will see. No, I'm just joking, of course. But so now this talk comes from an article that I recently published in a mathematical review, and the article talks about a section of a workshop about the 4th dimension that I've created in 2012 for some scientific festivals. So one section was about games in 4 dimensions. The aim of this workshop was to proceed by analogy, and so to clarify how 2-dimensional beings, like a square, for example, could perceive the 3rd dimension. Okay. So, for example, if this is a projection, okay, this is 3D. Do you agree? Okay. The shadow is 2D. Okay, and so a b-dimensional being, a square that is moving on this plane, okay, could try to have an idea of my hand, seeing different shadows of my hand, okay, and so could have an idea of the 3rd dimension. Now, by analogy, we 3D beings could have ideas of the 4th dimension, seeing 3D projections of 4D figures. So the whole workshop works by analogy. And it recalls also Plato, the myth of, I don't know, the mito della caverna, how do you say it? The cave, yes. And mostly I cite Flatland, a novel by Edwin Abbott, the end of the 19th century, that talks about a 2D world in which characters are squares, circles, triangles, and in which a sphere comes and chooses his own prophet of the 3rd dimension. So reveals himself to one square that will become the prophet of the third dimension in this flatland. Okay, now let's go to the games. First of all, so the aim is to show the didactical power of some games to help understand abstract mathematical concepts, and in this case, the fourth spatial dimension. I didn't introduce myself, actually. I'm program manager of the Italian Festival of Mathematical Games, that is every year at the end of July in Italy, and on the Lago Maggiore. And I deal with scientific popularization, so I create exhibitions, workshops, and give talks, mainly about games and mathematics. So about games and about mathematics and the connections. So I have found 4 games that include this idea of fourth dimension. One is Quarto. 3 of them are here. One is Quarto. We are going to see them. One is Set, a card game. One is 4D Tic-Tac-Toe that I have invented, actually, or at least I'm not aware of any other similar game. And Kvataro, this is the Connect 4D, so Connect 4 in 4 dimensions. In case you are aware of other games in which can be seen in 4 dimension, please tell me. So to begin, Quarto, where are the 4 dimensions? Let's say that each piece have 4 characteristics that are independent. And for each characteristics, so we have the shape, can be round or squared, color, black or white, height, high or low, and filling, empty or full. At the top can be empty or full, okay? So these are the 4, these pieces can be represented in a 4-dimensional space. Now I'll explain it better later for other games. This is less interesting. Anyway, the question is how many different pieces? 16, yes. How did you calculate it? Exactly. 2 to the power 4. 2 is the number. So 2 is the number of states. For each dimension, we have 2 states, black or white, high or low, etc. And 4 is the number of dimensions. Okay, so 16. Good. Sorry. The goal is to create an alignment of 4 pieces such that in at least one dimension, they are all equal. For example, can you see here a winning alignment? Yes, empty on the diagonal, okay? On the diagonal, there is one dimension, that is the last one, in which they are all equal, they are all empty. Now let's go to see Set. In Set, also there are 4 dimensions. The shape, so each card can be ovals, squiggles, or diamonds. Then the color, red, purple, or green. The number, 1, 2, or 3. The shading, solid, striped, or outlined. Okay? In this case, how many different cards are there in the deck? 81. So once again, these are the 81 cards. And once again is the number of states elevated to the number of dimensions, because in this case the states were 3 for each dimension. So 3 times 3 times 3 times 3, we get the 81 cards. In Set, you distribute 12 cards on the table, and then you have to find a win set. A win set is a group of 3 cards such that in each dimension, their states are either all equal or all different. So, for example, in example number 1, the color are different, all different. The shapes are all different. The filling are all different. And the number also. Okay, so everything is different. Here, in the number 2, the color, for example, is all equal. So it's also okay. And the number also is all equal. Okay? The number 3 is not a win set. Because, for example, the filling is not all equal and not all different. There are two equal, the first and the third card, and the central one is different. Okay? So in this case, this is not a win set. Now, so this is how we play. We put on the table these 12 cards. Now I will simplify the thing. Let's take only 6 cards, and now let's play. Can you find a win set in this among these 6 cards? Yes? Yes? Yes, correct. So this is a win set. Okay, anyway, you have understood the concept. And these are students playing during my workshop. Now, let's go to another game. First of all, let's see the 3D tic-tac-toe. In tic-tac-toe is bidimensional, right? 2 dimensions. Now, if we accost 3 bidimensional tic-tac-toes, we could play in the 3rd dimension. For example, if we play a circle on these 3 points, okay, we can get an alignment in the 3rd dimension. I will show it better later in another slide. Also, this one in the 3rd dimension is an alignment. Let's see how. This is the 3D figure, okay? The first one, if we put one on top of the other, okay? In the first one we have the 3 circles there. So they create an alignment in the 3rd dimension. And this also is an alignment because it's the diagonal of the cube. Is that clear more or less? Yes? Okay. By the way, did you realize where this tic-tac-toe come from? Yes? Where? To the pair, exactly. Well seen. Now let's go to the 4D tic-tac-toe. Okay, this is a game of gigamic. It's called Cubulus. It's not a tic-tac-toe, but I have used it as a tic-tac-toe. This can be used to play 3D tic-tac-toe. Okay? Now, if by analogy, previously we have put 3 normal tic-tac-toes, one after the other, and we have created the 3rd dimension. Now, if we put 3 of these, one after the other, like in this picture, we can create the 4th dimension. And I think the core of my talk is this image, because children at the age of 6 or 8, and I'm talking about some thousands of children that participate, children or adults also, that participated in my workshop in several festivals and schools, understood immediately the concept just by playing. And I think this picture shows quite well the interest of the child. In this case, the child has played in the 3 centers of the 3 cubes, realizing a 4D alignment. I have to precise that the rules are not that the first wins, otherwise the first player would always win. We have 15 balls each. We play every one, so one alternatively. And each time we play, we check if we have realized alignments, and we get the points. And at the end of the 15, so 30 balls, the winner is the person with most points, of course. Okay, so how many different places? $81 too. One more time. There are 4 dimensions, and each dimension has 3 states. First floor, second floor, third floor. So once again, number of states elevated to number of dimensions. And here we can see, for example, the blue. This is a winning alignment, or the red that the child had done, or also, for example, the green. Because, why the green? Because if we imagine to superpose the three cubes on the same cube, the three green balls would constitute an alignment. Okay, just by analogy with the second situation here. Okay, when we superpose on the third dimension, the three crosses create an alignment. And this is a moment where the scientific explainer is explaining exactly this concept, showing the three cubes and showing how to imagine the fourth dimension by superposing the cubes. And finally, the last game is Kvataro, or Connect 4D in English. The name is in Esperanto because the author is an Esperantist. But in English, I thought about this name, Connect 4, but 4D because it's 4 dimension. And it's the game that you have seen probably in these days there, and you can see also here. It's like Connect 4, but 4 times, so you can play also, it's just an analogous of this 4D, but with 4, more or less with the gravity, but I mean, it's just like Connect 4 in 4 dimensions. I'm not going to talk about it.
Can I ask a question?
Sure.
How come there are 6 components in this game and 3 in the Tic-Tac-Toe 4D?
6, huh?
I don't see 6 here.
No, there are 4.
There are 4.
Yeah, and this is just for pawns.
Oh,
Yeah,
okay.
so
Okay.
there are just 4. Yeah. Now, once again, how many different places for this game? Exactly, 256. So 4 to the power 4. Once again, the number of states that in this case are 4 to the number of dimensions. Okay, how many minutes do you have still? 10 minutes? Yeah, no, maybe more. Okay, so now one last, I would say the core was done. Now one last part that is something deeper, but not so much. Anyway, don't worry. So we do a comparison between set and 4D tic-tac-toe. So in set, you want to find win sets. You remember, a set of 3 cards such that in each dimension, the states are either or equal or all different. In 4D tic-tac-toe, you want to do alignments. Now, we could ask a question, and that we do that in the workshop, in order to think in 4 dimensions and try to calculate something about the 4th dimension. So, for example, are there more win sets or more alignments? You have any ideas? You say more alignments? No other guesses? Answers? Okay, let's see together. First of all, let's simplify to 2 dimensions. In the workshop, I do also in the 4 dimension, but here on the screen would be difficult. So let's simplify to 2 dimensions. The concept is the same anyway. So we can take only 2 dimensions and put them like in a tic-tac-toe, okay? And so now we can take these 3 cards, okay? Now in tic-tac-toe, so we are going a mapping of the 2 games, okay? Now, is this an alignment? Yes, because if you do that in tic-tac-toe, you win, right? So it is an alignment. And it is a win set. Is it a win set? Yes, in 2 dimensions, yes. Because in all dimensions, they are, in 1 dimension, they are all equal, because 1, 1, 1. And the other, the shape, the filling are all different. So it is a win set, right. And what about this one? Is it an alignment? Yes. Is it a win set? Yes. Yes, it is. Both dimensions are all different. Good. What about this one? Is it an alignment? No. Is it a wind set? No, it's not. Because in the filling, for example, you have shaded, shaded, and full. So they are not all equal and not all different. Okay. So now, until now, we have seen sets that are at the same time alignments and wind sets, or not alignments, not wind sets. For the moment, we could suppose that the number is the same of wind sets and alignments. Now, how can we try to go a bit further? The idea is, can we find an alignment that is not a wind set? And can we find a wind set that is not an alignment? So this is the question for you. No? So you think that the number is the same, wind set and alignment. Okay. Any other proposals? Nick? It's not the same. So if you're not the same, you should find at least an alignment. So what do you think? More alignments or more wind sets? More wind sets. More wind sets? Okay, you say more wind sets?
Yeah, yeah. 1A, 2B, and 2C.
Exactly. So let's see. This one is not an alignment, right? But it is a wind set. Okay? So there are more wind sets or alignments? Wind sets, yes, it was correct. Okay? So, well, this was just a little example on how we can go on, and of course, this is just a short presentation. But there is much more. Thank you very much. Dankon. So, of course, we are ahead of time. So, in case you have straight away you have questions straight away, you can just ask now. Otherwise, later. In the time being, I just add that this whole workshop was inspired by a movie, an animation movie by Etienne Gis, professor of mathematics at the University of Lyon, that is called Dimension, or Dimensions. It is in 7 languages. And so the idea is what I have explained at the beginning. Yeah, there are 2 parts. One through the projections, like this one. Okay, so understanding by analogy the 4 dimension through projections, and another one is through sections. You can do sections. So this was my inspiration. Now, yes, Nick.
Take that game which is over there in your hand, please. The one you've got there. No, that. When you put 3 of them together,
yeah,
right, you've got the 4 dimensions.
Yes.
Okay?
Yes.
Now, when you make a grid of 3 per 3 of that, how many dimensions is that?
3 times 3. So 9 of them.
Yes.
5th dimension.
And then when you make a cube, 3 and 3, we are talking about the game in 6 dimensions.
Yes.
In your
yes.
terminology.
Exactly.
Okay, thank you.
Yes.
Would be a nice idea to play.
Yes. Next year I will I will implement. Really? Yeah, I could. There was Alex probably.
If you have a regular deck of cards and you have 2 decks that are different, you immediately have the possibility to play 4 dimensions.
2 set cards? Yes. No, 3 set cards. No.
You
2.
You have suits. You have
2. No, not set cards. No, normal cards.
normal, yeah. Regular
Sorry.
Cards, regular playing cards. And
Yeah.
you have 2 decks that are differentiated. One is blue, one is red on the back.
Yes.
You have 4 dimensions.
So you have, yes, because, no, why? No, let me.
You have the suits, you have the numbers, you have the colors. And then you have the 2 decks.
Yeah, I understand. Yes. Yes, but the number of states is not the same in each dimension. But yes, it is in 4 dimensions. Yes. Yeah, there was probably No, there was first. Yeah. Yes.
You asked an idea of the dimensions.
Yes.
I'm giving to you.
Thank you very much.
Every Saturday I solve the Sudoku in this 5 times. And what I try to do every Saturday is only fill up the middle square. So I'm seeing the other ones, but I have to recognize with all the figures what I've seen. And is it what I don't see, is that the second dimension, or is it the same dimension or another dimension? I can see.
Yeah, thank you very much.
To recognize what I have counted in my head.
Yes.
And what's got?
Yeah, Sudoku is 9 by 9. So if you you can easily think about the 3D Sudoku with 9 Sudokus, one on top of the other. And then if you take this 9 times 9 times 9 cube and you put 9 one after the other, you will be playing the 4D Sudoku. But I don't know if anyone is going to prepare that for you. Okay, George.
Well, just to a curiosity, do you know how set was invented? The game of set was invented by a researcher in genetics in Cambridge, and she was studying epilepsy in dogs.
Wow.
And that's where those cards come from. It's very nice.
Okay, yes. Yes, interesting, interesting. One thing I would like to add is that studying the 4th dimension many non-mathematicians can think that's completely useless, more or less useless as saying if in medieval time draughts or chess were most played, for example, just to do a little joke, but.
He's not laughing.
But I can tell you that at the same time it's not useless what we discuss here, and it's not useless also to do abstract mathematics. For example, mathematics have many applications, and the GPS can work thanks to relativistic calculations, so the Einstein relativity. And the Einstein relativity is based on 4 dimensions, 4-dimensional mathematics. So this is just to tell you that we talk in the workshops also about applications. So understanding the 4 dimension is then more than a game.
Okay, thank you.
Thank you very much.